Okay, this is my first Q&A, questions and answers. So people wrote in, so let's just get right into it and see what people have to say. Somebody wants to know projects for beginning oscilloscope users. Yeah, I would say 555 timer. 555. So just build a 555 timer and have it oscillate. And take a look at the output with your oscilloscope. Try to measure the period, try to measure the frequency. And then on the input, you will find a capacitor, and that capacitor will have some charge and discharge, waveforms. Try to measure the bottom of the waveform and the top of the waveform, and they should be about 1/3 and 2/3 of the way between ground and plus V. So yeah, I would start with that. How do I learn electronics? I have a degree in it and know some basic things, but I want to build stuff. Okay, so this is a reoccurring theme in my channel about learning electronics and doing electronics. So this is, when I read this, I get sad. Somebody says they've learned electronics, they have a degree in it, right? They have a degree in it. Is it a AA degree or an EE degree? I don't know. So they say they know some basic stuff, so maybe they have an AA degree. But now they want to build stuff. Yeah, there's a big disconnect between learning the theory and then actually doing things on the workbench. You've got to do, you've got to build, and you can't be scared to do it. You just need to start doing it. So you want to build stuff? Yeah, start building stuff. Just start building stuff. Whatever you can imagine, right? You know, turn on an LED, blink an LED, turn on a motor, make an audio amplifier, make something, make a buzzer, make a tone, just build stuff. The other thing I would say is, if you don't know how to build stuff, look at what other people have done, right? So I think one of the most valuable ways to learn is to tear things apart, right? You say, oh, here, I've got this calculator. How did they design that? You know, tear it apart. Get one that's broken, right? Go to the thrift store, buy an old, you know, stereo amplifier. Take it apart. Oh, here's a power supply. Oh, look, they used this wire. Oh, that's a transformer. Oh, that's a... Look to see how other people have done it. So if you can get to the point where you can repair things, then you can design things. I would say it's more important to learn how to repair things first and then start designing your own stuff. Because in repairing things, you have to figure out how other people have done it to repair it. And then you can say, oh, okay, I know that idea now. I can use that idea in my application, right? Oh, that's how they generated a clock. Okay, well, if I ever need a clock, I'll just do what they did, right? So that's what I would say. Here's a lurker that was prodded into commenting. What was your day job? Okay, so I am fully retired. I have been since 2018. I retired from the typical workforce in 2014. So for 4 years, I've had my own company. I did consulting and expert witness stuff. So my last real job was as a consultant. My consultant was in the area of optics, so I did lens design, and I should back up a little bit. Silicon Valley optics engineers were nowhere to be found. And in the last decade, suddenly optics engineers are in great demand because of people doing VR displays, AR displays, different types of displays, doing cameras. Everybody and their brothers using cameras for other applications and stuff. And so optics is a popular thing, and there are very, very few optics engineers. So I was fortunate to have the right skill set to have a nice consulting business. The same was for expert witnessing. If you have a particular knowledge, I was an expert witness for Nikon. They were being sued over their camera technology, and I knew lots about cameras, and so I did that. So anyway, that's what I did. In your opinion, what's an overhyped technology? So I wrote down some ideas. You know, a couple decades ago, it was solar energy was way overhyped. It still is a bit overhyped. Self-driving cars, I have a really thing against self-driving cars. When I was doing real work, I would have companies try to sell me stuff. I'd always say call it selling me snake oil. One of the big overhyped technologies for cameras was diffractive lenses or computational optics. Those were just overhyped. Today, though, the winner is NFT. NFT is garbage. Sorry, it's overhyped. Underhyped. What is underhyped technology? I'll just throw one out. I'll say UV LEDs. So these are LEDs less than 400 nanometers, and in fact around 260 nanometers is kind of a really good spot to do disinfecting. So if you want to do water purification, these really low ultraviolet LEDs will be great. It's not a very sexy technology, so that's probably why it's underhyped. But for the third world countries and stuff that need fresh water and things, yeah, UV LEDs. If you go to Japan to a temple, there's like a UV lamp for the water at the temple. Anyway, it's a lot like that. It's just going to be super cheap and be everywhere. Okay, let's see. How did ham radio play a part in your career decisions? It didn't. Did it help you as you progressed in your positions in science and engineering? No. Did knowing a ham in an organization pay off because of immediate connection you made? Not because of work. I made some friends because they were also hams, but nothing to do with work. Okay. You've done a lot of optics and electronics. What's the best large area pin diode and transimpedance amplifier for very high speed pulses? There isn't any. You cannot use a large area pin diode for high speed because large area pin diodes have lots of capacitance, and lots of capacitance means it's slow. So no, you need small diodes. What's the best way to learn electronics in your opinion? So I did a, if you haven't watched it, I have a video on how I learned electronics, but it isn't the best way to learn electronics. I would say the best way to learn electronics is to get a double E and get a job. What happened to unijunction transistors? Yeah, unijunction transistors were pretty cool. I think they were drawn with a funny base thing like this. I forget now, but they had a funny little base symbol on the unijunction. And the way that you use them was to put a capacitor and a resistor on the input, and then it would charge up, and then it would fire, and then it would discharge. So it was like a 4-layer device. It would automatically discharge the capacitor for you at the same time. It would like kind of short out these PN junctions, and we'll have to charge up again, back and forth, back and forth, back and forth. Why did they go away? Because 555 timers got dirt cheap, and op amps got dirt cheap, and so you can just do those with those other devices. Okay. Can you demonstrate a totem pole using a 2N7000 and TPO, I don't know that other one, a TPO6, it must be a P-type thing. So I really don't do much with CMOS totem poles. I've done a lot with bipolar totem poles, or push poles, whatever you want to call them. If I was going to be using one, though, and I have, I would already buy something that's already done for me. The biasing of the two gate, you don't want them on at the same time. That would be deadly. So you need to keep them separate. It's like a Class AB amplifier, but they don't really like that middle region, so they're a bit finicky. They're usually a hard-on, hard-off application when you do that. Although you can bias them, but it's a little trickier. So H-bridges are something you can just buy and already has the push-pull thing in it. You can use that for motors and DC to AC rectification, audio amplifiers, you know, Class C, Class D, Class E type of stuff. Yeah, they're just off the shelf, so that's what I would do. Can you please explain an RF power amplifier and how it works? So there are lots of RF power amplifiers. I have covered some. Go look at some of my videos of where I repair ham radios, so yeah, go to my ham radio playlist. I think I repaired a Kenwood 430. I repaired an ICOM 746. They had power amplifiers in them. I also did a video explicitly on a power amplifier out of a 2-meter radio, 144 megahertz radio. So yeah, I've already done that. Do you find electronics to be expensive hobby? No. And do you have tips for making good use of the money you spend? Okay, so any hobby is as cheap or as expensive as you want it to be. I mean, maybe golf, you know, you're kind of stuck with whatever golf fees are and stuff, right? But you can get used golf clubs and things like that, but you still have to pay for getting onto the green. Well, this is in your garage, so you get to do what you want. So it can be super, super cheap. You can get really cheap voltmeters and things. I think it's cheaper now than it used to be because of China. You can get just fairly good stuff really, really cheap now. So I would say it's cheap. Have any tips on making good use of the money you spend? Yeah, don't keep thinking you need to buy the next best thing. The stuff you have is fine. If you want to buy newer stuff, great, you know, but only do it when you can afford it. But, you know, cheap stuff works just fine. I would say probably one of my best tips would be like a little box like this. When I go to breadboard, I have basically most of the things I usually use. 1K resistor, 10K resistor, 0.1 and 0.01 capacitors, and a 10 microfarad capacitor. And that's basically all I really need to do a lot of circuits. And so the idea of saving money is that when you take a resistor and put it into the breadboard and you're done with it, put it back and then use it over again. Just keep using the parts over and over again. Don't solder them. All right. Love your videos, thank you. When will you get back to other retro computers? I learned a lot. Yeah, I started out with the IMSAI. I have done a lot of videos, so go look at my playlists again. I have like 70 videos on the IMSAI. I did a series on, I think, 2 different 8085 single board computers. I did a Z80 single board computer, the Zeta. I did an Intel SPC board, which was an 8080. And recently I've done an Osborne computer a couple months ago. So yeah, just go take a look at those. I might do a K-Pro someday, but I haven't found one for a good price that I wanted. Let's see. In RF application, selectivity is determined by the Q factor. Lower the capacitance, the better the Q factor. Tanks through. Blah, blah, blah. Okay, so I would say that might have been true in the old days, but not anymore. Usually the front ends of receivers are very wide open these days, and it's relied, the IF filter is the thing that has the selectivity, and the IF filter can be a SAW filter, can be some different technology, it can be a crystal filter. That Q doesn't really come into it. I mean, it does come into it, but it's not a capacitor inductor type of thing. Like SDR radios, I mean, the entire bandwidth of nature goes into an SDR radio, and then all of the filtering is done in software. So, yeah, I don't know much about LC circuits. So, what makes a good engineer? How to become a good engineer? Hints for the workplace. Oh, God. That's probably a whole video all on its own. What makes a good engineer? So, passion. The very first thing is passion. Anybody can go to school and get grades and stuff like that, but it's passion. Somebody has to really like what they're doing and be really, really interested in what they're doing. How do you become a good engineer? Again, the same answer. I would like to actually say, what does it take to be a successful engineer? Now, there are a bazillion different types of engineers. My experience is mostly with R&D engineers. So they have a different skill set that's needed. So the comments that I make might not be applicable to a quality assurance person, or I don't know, somebody else, right? Marketing. There's all kinds of engineers. So if you want to be a successful engineer, my advice would be, again, passion. Find something that you're passionate in, and if you're lucky, you'll find something that somebody else is not passionate in. So let's say you are starting out, you got a job, and you're doing stuff, and suddenly somebody needs a low dropout voltage regulator, and you invent one or do something, it's battery powered, it needs to be low dropout, blah, 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 blah. And you become kind of an expert in power supplies, and you get to have a name for yourself. And then the next time somebody needs a power supply, say, hey, go to Joe, you know, he knows all about power supplies. And so you start being the power supply guy. And maybe you get really, really good at it. And then if you retire and you do consulting, then you have something you can consult that. So it's hard to consult to something, hey, I'm a double E. You're not going to make any money. You're hardly going to get any jobs. But if you're a power supply guy, then there are going to be companies who need a power supply guy, and then they'll hire you. So try to find a niche for yourself. But don't paint yourself in a corner either. Don't become the buggy whip expert, and then nobody wants buggy whips anymore. Okay, hints for working with different coworkers. I've had really good experiences and really bad experiences. And I'm probably not the best person to ask that question of. I'm very intolerant of people with egos, people who won't listen, people who won't share. I'm very intolerant of those people. And it's difficult. If you find people like that, it's very, very difficult. Be true to yourself. Try to be civil, but you don't want to end up in a workplace where everybody pats themselves on the back and you end up with a half-baked product. It's important that everybody be able to criticize. Yeah, it's important to be able to take criticism. Okay, I'm always curious with what type of power protection you use. Isolation transformer, blah, 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 blah. Okay, just a second. Let me show you what I do. So the AC comes in, and the first thing that goes into is a variac. So there's a variac. It comes out of the variac, and it goes into that thing back there, which is an isolation transformer. Okay, so definitely you want to have an isolation transformer. The isolation transformer then goes over to here, which is a volt amp watt meter, so I can monitor things. And then it goes into a box. Pull the box out. So it goes into this box. The box has an on-off switch, so it's right next to, so these are the clip leads I'm going to be using, so the on-off switch is right next door, and it's fused right here. So if anything gets shorted out, it'll blow the fuse right here. So yeah, that's what I do. All right, and you mentioned dim bulb tester. I have a dim bulb tester that I use once in a while, and I have a video on that, so look up dim bulb tester, not limiter, dim bulb tester. Okay, somebody wants to know, your IC7300 is usually in view, what types of antennas in view, blah, 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 blah. Okay, so yes, I do still have a ham radio, and I do turn it on once in a while. Oh man, it's really dark over there. Yeah, that's the radio there. I have a antenna tuner for 40 meters. This has a built-in antenna tuner that works on all the other bands, but I need that one for 40 meters. And I have a 2-meter 440 rig, which is a FT3DR. I have antennas on the roof. I have a J-pole that works on 2 meters and 440. I have an up at the top of the fireplace chimney, and it runs down over to a shed. So it's just a random length of wire with like a 49-to-1 on it. Works great. Works fine with everything from 40 meters to 10. Works great. Works fine. And I don't talk on the radio. The best you can, he says, can I talk to you? The best you can do is to maybe find me on FT8 or something like that. But yeah, I don't give out my call sign, so yeah, good luck with that. All right, maybe you can show us how a metal detector works. I did a metal detector. It was a Belgium kit time, and it was a little thing. Question and answer, tell us a few things of your life and role of electronics in it. So I kind of mentioned before, I wanted to be a scientist. I went to college. I was a double major, physics, mathematics. And in my senior year of physics, I really kind of discovered electronics, and it hit me hard. And I really wanted to do that. And I think it was mostly because microprocessors. I was really, really fascinated with microprocessors. So my school that I went to did not offer a double E degree. I might have stuck around for another degree if I had known, or that college had one. So anyway, my first job was in electronics. I worked, I did electronics for about 10 years. For about 10 years. And then I started doing more and more optics. And about the last 25 years of my life, I did nothing but optics. So I only do electronics here on YouTube because it's my hobby now. Okay. I am continually impressed when I look up the specs on your Keithley meters. Yeah, Keithley is totally amazing. But he can't afford those, so he would like to have an ammeter, though, that was good to nanoamps, but he doesn't want to spend the money. Yeah, you can build some pretty good nanoamp electrometer circuits using op-amps. Maybe I'll do one of those someday. Dave over at EEV Block has a nanoamp product that he sells. You might want to take a look at that. It converts amps into voltages so you can measure them with oscilloscopes and stuff.